Hey, welcome to the 18th lesson on C++. In the lesson, you will practically explore the use of classes and objects. You will become acquainted with C++ OOP, learn how to construct classes and objects based on them. Earlier in the course, we already covered data structures together. At that time, I explained that data structures are used to describe a small object. In other words, it's very convenient to describe all the necessary characteristics in one place, and based on this structure, you could create objects. When we talk about OOP, and in particular, classes, the logic is essentially the same. The difference is that structures usually describe small objects. Earlier, we described a tree, and similarly, we could describe a book, and so on. These are indeed small objects with not too many characteristics. In classes, more extensive objects are used, such as a car, a house, and so on. Such objects often have numerous characteristics. For example, let's take a person. A person has a name, age, desires, hobbies, and so on. But besides all these characteristics, a person can have functionality, such as the ability to walk, jump, squat, go to sleep, and so on. In other words, you describe the functionality required in your program. And when you need to describe a real-life object, if it's a large object, you describe it in a class, and if it's a small object, you can describe it in a structure. Now let's create our class. Just like with structures, we need to define the class outside of any functions. So, let me write the word class here and specify the name of this class. My class will describe certain buildings. Not a specific building, but rather abstract buildings. Later, we will create objects based on this class, and each object will represent a specific building. For example, a school, a kindergarten, a hospital, and so on. After the class name, we need to write curly braces, and just like in a structure, we put a semicolon here. Now, inside the class, we can write some characteristics or variables. As you remember from the previous lesson, variables in classes are called fields. But in fact, it's the same thing. We can also describe functions inside the class. These functions in classes are called methods. And again, it's the same thing. Now, let's describe the fields here. To do this, we first need to specify the access modifier. We will talk more about this during this lesson, but for now, I suggest writing the word public. And then we'll start describing the fields. We'll come back to this word a bit later, and I'll explain what public is and what access modifiers are in general. So, we declare the fields. Fields can be anything. You abstractly describe the characteristics that can apply to any of your buildings. For example, any building should have a year of construction. So, I want to create a field in year. Also, any building should have a type, whether it's a school, a kindergarten, and so on. Therefore, I will create a field called string type. Following a similar principle, you can write as many fields as you want. These will be characteristics for your subsequent structures. For now, I'll limit it to these two characteristics to avoid cluttering our program code too much. Now, let's create another method here. This method will display complete information about any object on the screen. And this method itself will not return anything. It will simply display information. So, we write void here. Next, our method will be called getInfo. The name can be anything. And inside the method, we will simply refer to the type of the building. So, first, we'll output some text, then refer to our type field, then we'll use a dot and output the year of construction. Finally, let's add a new line at the end. So, now we have a class. In this class, we've described several fields and also written a method to display information about our object. Now, based on the class, we can create specific objects, such as a school, a kindergarten, and so on. To create an object, we simply need to use the class name as the data type. In our case, it's building. Then I specify the name for the object. Let my first object be called school. Next, we need to access this object and set its type. Here, I'll write school. Let's once again refer to the object, and this time, we'll set the year of construction. Let's assume it's built in the year 2000. Now, let's refer to this object again and call the getInfo method. If we run the program, we'll see that all the information set for this specific object will be displayed on the screen. Here's the convenience: I can quickly create another object, and this time, let it be a house. Then I'll say that for this object, I'll be setting new values. Let's assume the construction date is 2010, and the type is house. If we run this, we'll notice that different information is displayed for the first and second objects. So, roughly, the same logic is being used now as we discussed when working with data structures. There, we also created structures, created objects, described their characteristics, and then worked with these objects. At first, it might seem like OOP and describing all these classes are unnecessary. But believe me, in the future, you will constantly work with it. OOP is a very convenient concept, even though it may seem meaningless at first. Now let's consider what access modifiers are. We've already written one access modifier, public. There are also others, such as private and protected. With access modifiers, you can specify the visibility for your fields and methods. When we write public here, it means that all fields and methods inside the class will be accessible from everywhere. We can work with these fields and methods both inside the class and inside different objects created within this class. Now, instead of public, let's write another modifier, private. And now, any of our fields and methods are only accessible within the class. So, inside the class, I can still access these fields, and there will be no errors. But here in the main program, it hints and underlines these fields in red. This happens because we are trying to work with values that have a private access modifier, and I can no longer access them through the object. Now let's change our access modifier to protected. We'll talk about this access modifier when we study the topic of class inheritance. For now, I'll just tell you that with this modifier, all fields and methods are accessible both within this class and in the inheriting classes. We'll discuss inheriting classes a bit later. For now, let's understand that our program currently sees errors. So, let's return our modifier to its initial state and make sure everything runs correctly. There's another detail worth mentioning here. In OOP, it is commonly accepted to mark all fields with the private access modifier. In other words, there should not be direct access to fields. So, let's do that. I'll write this access and place two fields there, the year field and the type field. In the public access modifier, I will leave only the getInfo method. As a result, when creating an object, I can still access our getInfo method. Also, when calling the method, I can access the fields that are inside the method. But at the same time, through objects, I cannot directly access fields such as type or year because they are now private. You might think it's a bit silly, and why write them like this? However, in OOP, there is a rule called encapsulation. This rule states that all your fields should be closed from direct access. In other words, all your fields should have private access. Therefore, I suggest adhering to this rule. In principle, our lesson is coming to an end. In this lesson, we have briefly acquainted ourselves with the creation of classes. As you can see, classes are very similar to structures. Here, you can specify various access modifiers, and you can also create objects. To each object, you can add characteristics. And essentially, each object is, in fact, a real-life entity, as in our case with a school and a regular house. Well, that's it for me in this lesson. If you enjoyed it, don't forget to subscribe to the channel and like this video. Thank you all, goodbye.